G'day, I'm Neil and my handle is Wiley11. I'm just going to put my disclaimer here. Whatever I do and say on these videos is well-intentioned and well-meaning advice. I accept no liabilities whatsoever for any disclosures. If you take some advice or act on something that I'm saying on these videos, you do so entirely at your own risk. I'm doing it based on my experience. These videos are my attempt to give back to YouTube for the help and assistance that YouTube has given me. So once again, you follow along or follow advice from these videos entirely at your own risk. Okay, and if you're not happy to do that, click this off and off you go. Because this is purely my attempt to give back to YouTube, as I said, for the help and advice that I have received out of YouTube. So this is just my little attempt to give back. If you're happy to follow along at your own risk, buckle up, sit in. Let's get into it. Hey, and welcome back. I haven't been well. I've been a bit crook. Still a bit crook. But I want to keep moving forward with these series. This series is about the PWM, and this is part 2. And what we're going to do is take what we learned in part 1, and we're going to start to look at how can we create this with one of these chips. So this is a PIC 12F675. Now the reason I've chosen that chip, I don't need to choose that. I could choose something like, let's see what I've got over here. I've got lots of stuff everywhere at the moment. We've had workmen through and everything's in a bit of a mess. I could choose something like this. It's an Arduino, right? There's an Arduino board underneath controlling that. It's working on PWMs. So we can program Arduinos, we can program chips, we can program this flowchart up. And here's one I've prepared earlier. I'm going to save you me trying to use PowerPoint. You can see I've got Microsoft PowerPoint open, part of Office. It's an older version. I prefer the older version because I can run it on the local system without any dramas. That said, I just want to walk through what we've got here. So we start at the start, and then what we need to do for our inclusion file is collect our properties data. So in the previous example, we had our duty cycle, and we needed the percentage of the duty cycle that was active, so that'll go in there. We needed our frequency. That will also go in there, and we need the CPU speed of the processor that we're using. So those 3 bits of information are the minimum bits of information we will be collecting in there. We're then going to verify that that data makes sense. So what we're going to do is we're going to say, right, can our software deal with the data we've been given? Now, if the answer is no, well, if the answer to this is that we've determined there's an error, yes, there's an error in the data, well, we need an error message and we want to dump it out. We want to go, see you later. Now, that's a really good practice to get into. What you got to do is you've got to do all your validation early. So if you've got a dirty, great, long user interface form, right, and the user's going through and filling it out, and let's say they've got 100 bits of information that you're collecting that they've got to go through and fill out. They get all the way to the end and they go save, and you go, oh look, I'm really sorry, but at part number 2 up here, you screwed up and I can't use any of this and we're going to start all over again. Well, that user's going to hate you, right? Yeah, they are going to hate you with a passion because they've just given you all that data and you've gone, you know, it's probably taken them 10 minutes to fill that in, and if they can't type, it took them 2 hours. Well, they're going to hate you with a passion. Get into the habit of doing validation as quickly as you can. That's a really good tip. So we've only got 3 bits of data, so not going to be the end of the world if I've got to put them back in again. If we go through it and say, yep, that's good, we can do that, no problem. We'll go in and we'll set our PWM high. Now, on our chip, we're going to have a pin, right? Usually a general purpose input output, a GPIO. There are other assignments of pins. There's analog. There's all sorts of different assignments you can make to pins. We're just going to use a GPIO pin, right? And we're going to send a signal, a high signal out. And then we're going to go to sleep because we don't need to do anything else until we hit the end of our active duty cycle. So until the end of that, we're going to keep that in sleep mode. Now the reason we're looping this is that sometimes with some chips, the sleep mode doesn't happen for as long as we need it to, and we need to add a bit on, right? So we keep putting it back to sleep until our cycle finishes. And when we hit the end of that, we go, oh, okay, we hit the end. Okay, yes, right. Now what we need to do is turn the pin off. So we get out, we've got our high, now we've got our off, and now we're going along, and we're doing the same thing. We're going to sleep until we hit the end of that. So what we're doing is we're saving power, right? We're being really efficient with the chip. Now that's as good as it gets in terms of what I know of. There's probably other ways to do this. That's my way of doing this. So turn the pin on, put the chip to sleep. So the power is basically running through a switch. We've used the chip as a switch. Chip's gone to sleep, turn the pin off. Chip's gone to sleep, turn the pin on. Chip's gone to sleep, turn the pin off. Chip's gone to sleep. Now we've got this thing here, a system interrupt. So what we are saying to our programmer is, look, until such time as that system finishes, right? Until something else happens. So maybe some other external influence has come in and said, we need to interrupt your process. Right, no worries. Now, we're going to keep doing that until we get a system interrupt. Now, that's fine. We'll run this routine. It's going to go around in a loop. And the way we break that loop is with a system interrupt. And they can be programmed in fairly simply. So when we end, we don't just go, all right, here you go, and leave everything in some state of limbo, right? What we got to do is think about, what did we do to the pin? Is someone else using the pin after us? You know, we don't know any of that. We want to be good little munchkins, and what we want to do is we want to say, right, we're now releasing the pin, right? And we want to, if we can, set everything back to the default system settings, so that when we come through and we set the system settings in here, right, collect and set this data in here, we're doing that neatly. We're not doing that, we got no idea how someone else has left that for us. You know, no, like the manufacturer might have done something, the guy down the road might have done something. Anyone can do anything. And what we're doing is we're making no assumptions on our bit here where we start, right? So we've got to do all our setup and our collect. And then when we finish, we're going to leave it the way we found it, right? If we can, if it's got something going on, well, we want to see, you know, release that, whatever it was. Now, that's a good habit to get into too. So that's our flowchart. That's what we're going to do. And from this, we're now going to sit around and work out how to build this include file, right, this module. We're not doing the whole program. We're not dealing with the magnitude. We're not dealing with the debounce. We're only dealing with the PWM, the square wave. That's it. We're not worried about how big it is. We're not worried about how clean it is. We're not debouncing it. All we're doing is outputting it. That's all we're doing. Now, the things we are worried about is how long does it need to run for, how many times a second, and what percentage needs to be high. That's it. That's all we're dealing with. And that's exactly what our flowchart tells us. Righto. I'm going to put this up in the include files for this particular project when we hit the repository. The link to the repository will be in the description for this video. So we are creating a repository. I am releasing code. I am releasing all of the planning so that you can see what I feel is a good way to go about your business. Other people will have different ideas. I've got no problem with any of that. This is the way I do it. And there are probably more efficient flowcharts, you know, there are probably, but this was the way I thought about what I was doing. This was my plan. I went from my start, I went through and did some stuff, I did some sanity checking. If I get an error, I want to throw it out. That's quite clear. Error, yes, any kind of error. Don't care what kind of error I get. I'm not making any decisions or assumptions. I'm throwing it out straight away. I collect all this data. I go, oh no, I can't run, and I'm going to give you a warning message. That's it. That's what I'm going to do. Over here, I've got my PWM out, sleep, blah blah blah. Away I go. Oh, there it is. Job done. Okay, so we have a flowchart. We have a plan. We've got some idea of where we're going to start, where we're going to end. Right? We've got a start and an end. And we've got an idea of how we're going to get from the start to the end. We don't know what those bits are yet, but we can see we've got some repetition going on. Our flowchart has helped us to identify that, and we can write one method to do two different jobs based on different parameters. So we can do a method, for example, to set the PWM pin, sleep, and wait. We're going to change the amount of time it waits based on the duty cycle. So set it active, wait till the duty cycle expires, active duty cycle expires. Set it inactive, wait till the balance of the duty cycle expires. Same method, you can reuse it. That's cool. I like recycling my code. I like being able to identify things like that from looking at this flowchart. Now the way it'll come together is you've got to set all your parameters and sanity checking at the start. The second you get something you don't like, you should throw it out. Right? You shouldn't run through 57,000 user inputs to say, look, at number 2 you gave me an invalid thing, I need to throw it out. I can't use any of that 57,000 bits of information. That user is going to get so frustrated with you, he's going to want to shoot you, right? Okay, you don't do that. As soon as you work out something's invalid or doesn't fit, or the user, you've got to think about the user. You've got to think about how's this getting used. And we've done that. We've done that, right? We've said we're putting out a square wave. It's going to get used in some device where they're going to tell us how long they want it to run for. Right? They're going to give us a frequency. They're going to give us a duty cycle, which is going to be expressed in terms of seconds. Right? And they're going to give us a frequency, which is cycles per second, right, in hertz. And they're going to give us some magnitude that they want. They want 100% of VREF, and we can express that as a percentage too. The magnitude can be, so we can actually output a percentage. We're not going to do that. Our flowchart didn't deal with magnitude, right? We didn't worry about that, and that's fine because that can be controlled with other things. We don't have multiple digital outputs in this particular PWM. All this is doing is outputting a square wave. That's it. That's all we're trying to achieve. So we've ignored magnitude and we've ignored the debounce. Okay, so in our plan, we've accepted that magnitude and debounce exist and that they're going to be controlled outside of our include file. they can be dealt with somewhere else. And we've got to make that very clear to people that use our code. So in our commenting at the top, when we describe what our program does, we're going to say that. We're going to say we are not dealing with magnitude and we are not dealing with any debounce. Okay, that's up to you guys. So let's move forward. So if you liked what you saw, please like the video, subscribe to the channel. Don't forget to support my company, nightglowmanufacturing.com, so that I can keep making these videos. I want you to make good decisions, do good things, and let's all get along. Let's make life a lot easier for everyone when we all get along. And I'll see you guys at the next video.